Now we have an important Pascal law. There was a scientist, Blaise Pascal, which made us familiar with one more characteristic of liquid pressure. He formulated his experiment into a law, and this law states that the pressure exerted at any point on enclosed liquid is transmitted equally in all directions. Again, pressure which you exert at any point into a liquid which is enclosed in a vessel, it is going to transmit equally in all directions. Now I am going to prove this. You will get more knowledge about when I will be proving with an experiment. Let's say I have this a flask, a round bottom flask, in which I have few holes here. Let's say this is in hole, this is in hole. So I have few holes here. Right. So what I do is I fill it with water and I have a piston attached to it or fitted to it. Now what I do is I just press the piston. So when I press the piston, this liquid moves down and the pressure is exerted on the liquid, and liquids start oozing out from the holes. And we see that when the liquid which is coming out from the holes is moving with the same pressure. So again, I am explaining you again, this is what we want to prove, that when we are applying pressure by a piston on the liquid which is enclosed in a vessel, so when I just try to push it down, the liquid escape out from the holes, and the liquid which is escaping down from the holes is escaping with the same pressure. So this is what that means. The pressure which we apply is transmitted equally in all directions. That is why the liquid which is oozing from the holes, it is moving with the same pressure. So now we have few consequences based on it. I have two consequences listed for you. One is that the pressure exerted by water in oceans increase with depth. That means with depth, like if we will see that at the surface of the ocean, the pressure is comparatively less if we compare with the pressure which is at the depth. So that is why what you do is, like when the deep sea divers need to go dive inside the water, so due to high pressure at the depth, they need to wear the special suits. And you know that if they don't wear those special suits to withstand that high pressure, they won't be able to withstand that high pressure and their body might get crushed. So that means the pressure is more pressure increases with the depth, and that is why the divers also need to wear a special suit in order to withstand the high pressure. Likewise, we know that the deep sea fishes, that means which dive deep at much depth. So when they are brought up to the surface, suppose we are moving a deep sea fish to a surface, where that means we are moving a fish from the high pressure to the low pressure. So the difference in the pressure is so much that when we move a fish from from the deep to the surface, its body flow with high pressure because its body gets burst open. So when the body gets burst open due to the change in the tremendous pressure between the surface and the bottom, that is why their body just burst open and they just flow with the high stream with high pressure. So this is what is the consequence, which you can actually explain on the basis of Pascal law, which states that when a pressure is exerted on at any point on an enclosed liquid, then it is transmitted equally in all directions.